So last night for homework, you guys had to watch an Ed puzzle on solving basic log equations, and it went along with page 6 and 7 of your packet. So the video did numbers 1, 3, 5, and 7. What we're going to do here in this video is we're going to do the remaining problems on that page. Now, what I'd like you to try to do is I'd like you to try out the 3 examples on this page right here, so numbers 2, 4, and 6. They correspond with page 6 of your packet. I'd like you to try those out on your own based on last night's video. And then once you try them out, you can hit play and just kind of check your answers with what I'm going to do. Okay, so we know if we're given an equation with the word log on one side of the equation, the first thing we want to do is we want to change it into an exponential equation. So we want to get rid of this word log. So in order to do that, what we do is we circle the base and run the race. So I'm going to circle this base, and when I say run the race, I'm going to cross the finish line. I'm going to cross to the other side of the equation. So what happens when I do that is this word log right here drops off because the base is no longer holding it up. So this log drops off. And I'm going to bring my 64 down, and this x that was the base now becomes the base on the other side of the equation, so it's going to be base x to the 2/3 power. So we could rewrite that as x to the 2/3 power. All right, so what the directions ask us to do is they ask us to solve for x. So if we want to solve for x, well, if you want to get rid of an exponential, well, if you want to get rid of an exponent on a variable, what we do is we raise both sides of the equation to the reciprocal power of what's here. So if I put both sides of the equation in parentheses and raise it to the reciprocal power of 2/3, the reciprocal of 2/3, just flip it upside down, is going to be 3/2. And you got to squeeze it right in there. Don't try to, it's an exponent, so don't try to write it over here on the top left just because it fits better. An exponent always goes on the top right. All right, so what's going to happen is when we have a power raised to another power, we multiply these. So 2/3 times 3/2, they just cancel each other out because this 2 on the top cancels with this 2 on bottom. The 3 on top cancels with the 3 on the bottom, and it leaves us with just x. Now over here, we want to figure out what 64 to the 3/2 power is. I mean, could you plug that in your calculator? Yeah, you totally could, and you can get an answer. But let's think about power over root. This means we have the square root of 64 to the 3rd power. So the square root of 64 is 8, and then 8 to the 3rd is 512. So we get x equals 512. All right, number 4. We're going to do the same thing. We're going to circle the base and run the race. So when we move the base over to the other side of the equation, the word log drops off, and I'm going to just bring down that x. And then the 81 now becomes the base on the other side of the equation, so the 1/2 becomes our exponent. All right, now this one, I mean, we already have x by itself on one side of the equation, so all we really have to do is just figure out what 81 to the 1/2 power is. So if we want to do that, we can again use power over root. So this means the square root of 81 to the 1st power. So the square root of 81 is 9, and 9 to the 1st power is 9. So there's our answer. Okay, and then number 6, same thing. To get rid of the word log, we're going to circle the base and run the race. So the word log drops off, so I'll bring down the 8, and the x becomes the base on the other side of the equation. So that leaves us with base x to the 3rd power. Now, this one is similar to number 2, where the x is our base. So if we want to get rid of, oh, you know what I'm realizing? On the handout, that's actually a -3. It's log base x to the 8 equals -3. So you know what? Let me put that in there. Let's make this a -3. So I guess that's going to be the -3rd power. All right. But anyway, if you want to get rid of an exponent that's on this base, we need to raise both sides of the equation to the reciprocal power, kind of like what we did here. So if you think about -3, -3 is the same thing as -3 over 1. So if we want to raise both sides of the equation to the reciprocal power, if you take -3 over 1 and flip it upside down, it becomes -1 over 3. And we're going to do the same thing here. We're going to raise it to the -1 third power. Okay, so what's going to happen is these are going to cancel out. That's what happens when you multiply reciprocals. And over here, I mean, if we do power over root, the only thing we have to remember is we have a negative here. Remember, if you have a negative, right, isn't this the same thing as 1 over 8 to the positive 1/3 power? So I'm going to write that out. We can rewrite this as 1 over 8 to the positive 1/3 power, right? We can bring, if we want to make an exponent positive, we bring it to the other side of the fraction bar. We bring it to the denominator. So now if we did power over root, we could say we have the cubed root of 8 to the first power in our denominator. So our numerator is still 1. So if we do the cube root of 8, that gives us 2, and 2 to the first power is 2. So that gives us a 2 in the denominator of our answer. So x is equal to 1 over 2. Now, to check your work, I mean, you could really just plug this into your calculator. You can plug in 8 to the negative 1/3 power, and it'll give you 0.5 or 1/2. So that's just a way to check. All right, so if you flip to the next page, we did 7 on the Ed puzzle. So if you take a look at number 8, I'd like you to try this one on your own. This one, I mean, it has the same concept. You know, circle the base, run the race. But it just becomes a more complicated problem to solve. But you guys can all solve this. I mean, we've done plenty of problems like this during the year. So give it a try, and then, again, you can hit play and see how you did. Alrighty, so I'm going to circle the base and run the race. So when I do, this word log drops off, and I'm going to take what I have here and just bring it straight down. So I'm going to bring down the x cubed plus x minus 2 over x, and then this base of x plus 3 now becomes the base on the other side of the equation. So on the right-hand side of the equation, we'll have x plus 3 to the second power. Okay, so I guess first thing I'm going to do is, I'm going to kind of expand this out. If we have x plus 3 to the second power, let's rewrite that as x plus 3 times x plus 3. And don't forget to bring down the left-hand side of your equation. And then we're just going to double distribute this all out. All right, so x times x is x squared. Now, I'm just going to skip a step here just to save, rewriting this equation again. Since x times 3 is 3x, and then 3 times x is 3x, if I combine the 3x and the 3x, that'll give me plus 6x. And then finally, we just want to do 3 times 3 to give us 9. Okay, and then I'm going to bring down the left-hand side of the equation. All right, so now I'm looking, and this side of the equation is a fraction, and this side isn't. So why don't we take this side and the right-hand side and put it over 1, just so we have a fraction on both sides. And then from here, what we can do is we can just, cross-multiply. You can multiply. Whenever you have a fraction being equal to, you need an equal sign there. Another fraction, just multiply the top left by the bottom right, and then you're going to multiply the top right by the bottom left. So, all right, if we multiply x cubed plus x minus 2 times 1, anything times 1 just stays the same. So that's going to stay as x cubed plus x minus 2. Okay, now on this side, when we do the top right times the bottom left, if I distribute an x to each of these terms over here, right, I'll have x cubed plus 6x squared plus 9x. So we'll have x cubed plus 6x squared plus 9x. All right, so we know we want to get everything to one side of the equation. So, if you notice, if we have an x cubed and an x cubed, if I subtract it from both sides of the equation, they're just going to cancel off. And then this is where I have my positive 6x squared term. That's going to be, our leading term. So I'm actually going to move everything to the right-hand side of the equation. So if I subtract x cubed, subtract x, and add 2, I'm going to do the same thing over here. I'm going to line that up like this. Okay, this will all cancel. So it's going to leave me with 0 equals, that cancels, 6x squared. And then I'm going to combine the 9x and the minus x to give me plus 8x. And then plus 2. Okay, so all we're going to do now is we're just going to solve this. I mean, you can use the quadratic formula if you want. I'm going to do it by factoring. So in order to factor, I mean, since everything here is divisible by 2, let's first just take everything and divide it by 2. That's going to make my life a little bit easier. And because I'm running out of room, I'm going to just kind of finish up over here. All right, so 0 divided by 2 is 0. And then if I take all of these terms and divide them by 2, it'll leave me with 3x squared plus 4x plus 1. So 3x squared plus 4x plus 1. All right, and now I'm just going to factor. So because we have a number other than 1 in front of our first term, we're going to do the rainbow. So that gives us a 3. So we have to come up with, well, first let's bring down the first term, leave a big space and bring down the last term, and come up with two numbers that multiply to this rainbow number here of 3 and add to 4. So 3 and 1. So we'll write plus 3x and plus 1x. And now we're just going to group. So it gives us 0 equals. Out of these first two terms, we can factor out a 3x. And when I do, in parentheses, that'll leave me with really just an x plus and 1, because 3x divided by 3x is 1. So x plus 1. Now here, it already says x plus 1, so we're really not factoring anything out other than just a positive 1. Okay, so if there's nothing to factor out, we're really factoring out a positive 1. So let's write plus 1, and then that leaves us with x plus 1. Okay, so we're almost done factoring. We're just going to group together the 3x and the plus 1 to create one of our factors, and we'll rewrite that common binomial factor of x plus 1. And then we make a t-chart, and if you set this side equal to 0 and solve for x, we get 3x equals negative 1, and divide by 3, we get x equals negative 1/3. On this side, we get x equals negative 1. Now it's really important to look back and make sure that if you take either one of these values and substitute it back in, it doesn't create a negative base or a negative log. And not just negatives, it can't create, I should say, a negative or a 0 base, or a negative or a 0 log. So for example, if I take negative 1/3 and substitute it in here, negative 1/3 plus 3 is a positive number. If I take negative 1 and plug it in here, negative 1 plus 3 is also a positive number. So as long as it creates a positive base, as well as, this has to be positive as well, then you can use both answers. If you take negative 1/3 and substitute it in to this fraction right here, so you do negative 1/3 cubed plus negative 1/3 minus 2 divided by negative 1/3, that does leave you with, believe it or not, a positive value. So this we can keep. Also, if you take the negative 1 and substitute it into this fraction wherever you see an x, it'll also create a positive value, so we can use this as well. So we have two answers here. Okay, so I'm going to ask you to do the same thing that I asked you to do for the other ones. I'm going to ask you to, with number 9 and 10, try them on your own first, see if you could do them. And if not, just hit play and have me help you out a little bit. Or if you think you got them, just hit play and see how you did. All right, so with number 9, we are going to, same thing we've been doing, circle the base and run the race. That gets rid of the word log for us. It changes it into an exponential equation. So when I do that, the 64 comes down, and the x plus 1 now becomes the base on the other side of the equation. Now make sure you put it in parentheses because you want to show that, this entire base is being raised to the third power. Now if you recall, if you want to get rid of an exponent, right, we need to get rid of this exponent in order to solve for x. What we can do is we can raise both sides of the equation to the reciprocal power. The reciprocal of 3 over 1 is 1 over 3. So we can raise both sides to the 1/3 power. Now, honestly, in this case, if you wanted to get rid of a cube, you could have also just taken the cubed root of both sides. That's up to you. It's really the same exact thing. Okay, so here, the 3 and the 1/3 cancel off, leaving us with x plus 1. And 64 to the 1/3 power, if we do power over root, it gives us the cube root of 64 to the first power. So the cube root of 64 is 4, and 4 to the first power is 4. And if you wanted to double check yourself, you can just plug 64 to the 1/3 in your calculator, and it'll give you 4. All right, so to finish solving, just subtract 1 from both sides of the equation, and that gives you x equals 3. I really shouldn't circle right away. I should make sure that when I substitute this number back into the equation, it doesn't create a negative or 0 base, or a negative or 0. I mean, we don't have an x here, so it doesn't matter in this case. But 3 winds up creating positive, so we're good. All right, and then number 10, same thing. We're going to circle the base and run the race. So when we do that, the 4 drops down, and the 5x minus 1 becomes the base on the right-hand side of the equation. And really, you know, same concept as number 9. If you want to get rid of this exponent, we're going to raise both sides of the equation to the reciprocal power. So I'm going to raise both sides of the equation. The reciprocal of 1 over 3 is 3 over 1, which is just 3. Right, so these cancel. So I could bring down on the right-hand side the 5x minus 1. And one thing I want to point out, please make sure that you're doing 4 to the 3rd power, okay? Make sure you're raising this. Make sure this is an exponent. A lot of people on accident do 4 times 3. We're not multiplying here. We're raising the 4 to the 3rd power. So 4 times 4 times 4, which is 64. And then we'll just finish solving this. So we're going to add 1 to both sides of the equation. So that gives us 65 equals 5x, and then just divide by 5. All right, so that gives us x equals 13. I'm just rearranging the order here. Okay, so there we go. And that 13 doesn't create negatives or zeros anywhere, so we're good to go.